In the previous videos, we talked about intervals, and we use intervals frequently to be the solution to an inequality. So I know we've seen inequalities many times before, but let's go over just a couple of the properties. Many of them are the same as equations, but not all of them. So some properties of inequalities. Let's take three real numbers. A, B, and C are elements of the real number line. So A, B, and C are real numbers. A is less than B, so it's left to the left of B on the number line. Well, if A is less than B, what can you tell me about A plus C compared to B plus C? Well, it's also less than. A plus C is less than. A minus C is less than B minus C. We know that. We know that if you have a less than, A is less than B, you can add or subtract a number to both sides, the same number, and the inequality, less than, stays the same. If C is a positive number, then when you multiply A and B by the positive number, you're multiplying A by C and you're multiplying B by C. The inequality remains. And if you divide A and B by the same number C, the inequality remains. That's because C was greater than 0. Here's the difference between inequalities and equations, one difference. If C is less than 0, that means C is negative. Then AC is all of a sudden bigger than BC. So this inequality, when you multiply both sides by a negative number, you've got to reverse this inequality. And same thing when you divide A and B by a negative number. So here's the caution that you need to memorize. Just remember, you must reverse the inequality when you multiply or divide the inequality by a negative number. Don't forget that. All right, let's do a few examples here. The first example, here's an inequality, and we're going to write the inequality. We're going to solve it and write it as an interval, and also we're going to graph the solution. So, what I want eventually is to have x, inequality, a number. So this could be less than, greater than, less or equal, greater than or equal. I know it's going to have the equal sign on it in this one, but let's get the negative 3x by itself first. I want to have the x on the left-hand side. So subtract 8 from both sides. Negative 3x less or equal, that looks like 9. All right, we already have to use this important reminder. Divide both sides by negative 3 means we reverse the inequality. And we would get x on that side because the negative 3's cancel, and negative 3. So this is the set of all numbers that are greater than or equal to negative 3. So if I were to draw it on the real line, I'd put negative 3 somewhere. Greater or equal, because it's got the equal, means I fill in the circle. Greater than means go to the right. Everything greater than negative 3. Greater than or equal. And you don't, this is optional, but you can put infinity out there if you want to. That makes it really simple to write the interval. This is the solution. Written as an interval and written as and graphed on the real line. Goes from negative 3, solid circle, square bracket on the interval, because it includes negative 3 because of that equals portion of it. Negative 3 and everything to the right. Okay, next one. All right, so we've got an inequality. I want to get all the x's on one side. So I'm going to subtract 2x from both sides. I like to have the x's on the left. Negative 5x minus 6 greater than 9. And now we add 6 to both sides. and I get negative 5x greater than 15. And once again, we've got to remember this reminder here. You must reverse the inequality when you multiply or divide by a negative number. In this case, negative 5. Cancels. And reminder that we had to reverse it because we divided by negative 5. So that'd be a negative 3 there and an x there. So this is the solution. Let's graph it first. X less than negative 3 means open circle because there's no equal sign under the inequality. X less than means we have to go to the left of negative 3. And optionally, you can put the negative infinity out there. Oops, I didn't write down the interval. The interval would be just negative infinity, negative 3. With open brackets. Sorry, I should have put it like that. By the way, if I didn't mention it earlier, if you have infinity, positive infinity would always be on the right, negative infinity is always on the left, and it always has a open parentheses, not a square bracket. Okay, well, we've got more examples to do in the next video, but I want to show a couple of unusual solutions that you need to understand. So this will have some unusual solutions. All right, let me first distribute on the left-hand side to get 4x plus 16. Greater or equal 4x plus 6. Subtract 4x from both sides, and what happens? 16 greater than or equal to 6. The x's fell out of the inequality. Well, that happens once in a while. And what does that mean? Well, let me ask you this. Is this a true statement or a false statement? That's true. True. So that means that no matter what value of x I plug in, I'm going to get a true statement. So that means every value on the real number line is a solution. That means that solution, all real numbers. Now, that's one way of writing it. You could just use that fancy symbol, r. You could also write the interval, negative infinity to infinity. All three of those are perfectly fine. They mean exactly the same thing. All real numbers, this is the set of all real numbers, the symbol, that fancy r, and so is this. It means the entire real line. And there's another way. Let's write it down as the set of all x such that x is in the real numbers. That would be considered set builder notation. So any of those four are perfectly fine. Let's look at the next one. Another unusual example. X plus 19 less or equal x minus 4. Subtract x from both sides, and guess what? Once again, the x's dropped out, leaving us with 19 less than or equal to negative 4. First question, is this true or false? That is false, period. I'll write it down. That means that it doesn't matter what value of x you plug into the original equation, it's not going to be a solution, part of the solution set. So in this case, solution, no solution, which you can just write like this, the empty set. Or you can write the empty set like this if you prefer, squiggly brackets with nothing inside. Okay, so just as a summary for the last two problems that have unusual solutions. If in solving it, all of the x's drop out, like they did in both of these cases, if you get a true statement, the solution is going to be all real numbers. If you get a false statement like this one, there is no solution.